Pre-calculus chapter 6 review. So here we have a few informations that I would like to go over before we go into the review. Law of sine. So there are two alternative forms for law of sine. One is if you're looking for the side, make sure you put the side on top. A over sine angle A equals B over sine angle B equals C over sine angle C. So it's always the side right across from the angles that you designate. We write it in a small letter form. So on the same note, if you want to find the angle measurement, put the sine angle on top. So we have sine angle A over side A equals sine angle B over B equals sine angle C over C. So make sure which one you are looking for. This way, you can save a few steps for solving the problems. And how do you find the areas? For law of sine, you will need 1/2 of AB times sine angle C, or 1/2 BC times sine angle A, or 1/2 AC times sine angle B. It is always the included angle. So please note, it is always the included angle. Meaning, for example, AB forms angle C. So in order for you to calculate a triangle area, you will need A, angle C, and B, the included angle, side angle side. And that's what we use for law of sine. Followed by law of cosine. So law of cosine states that the missing side, for example, A, if A is your missing side, then you need the information for B, C, and then angle A, the included angle. So A squared equals B squared plus C squared minus 2BC cosine angle A. So don't forget, this is squared to the second power. And the alternative form, if you are given all three sides, you can find any of the angle measurement. For example, angle A, if I want to look for angle A, cosine angle A is going to be B squared plus C squared minus A squared over 2 times B times C. So notice, the angle measurement you're looking for is the side being subtracted, so minus A squared. And then don't forget on your calculator operation, everything on top, B squared plus C squared minus A squared, needs to be evaluated as the whole thing. So make sure you put a parenthesis. And in the bottom, 2 times B times C is the whole thing. So make sure you put a parenthesis as well. So everything on top is being divided, everything at bottom. So put the parentheses. Otherwise, the calculator will mess up your order of operation. So check that every time before you begin your process. And one last thing, you have to check your mode. It's in degree or radian. That's the first thing you want to check. If I give you degree, make sure you set your calculator to degree. If I give you radian, make sure you check it and set it to radians. Or you can simply convert radian to degrees. Now let's take a look at the review problems. Here we have 4 questions. So depending on what are the information given, I note it next to my questions. For example, number 1, I have side A, I have side B, I have side C. So that's designated as side, side, side. Number 2, I have angle A, I have side A, I have side B. So that's S, S, A. The A is not the included angle. The angle is not the included one. Number 3, we have the angle A, we have side A, we have side B. Again, this is the case of side, side angle. Number 4, we have angle C, we have side A, we have side B. So have you noticed that the 3 letters are different? So it's going to be side, angle, side. The angle is included. So think about all these cases. Which one will give you unique one solution, one triangle solutions? Which one might give you more than one solutions? Side, side, angle. So as I mentioned, It's going to be on your chapter test, and you might see it on your extra credit problems. Now, back to question number 1. You are given 3 sides, side, A, B, C. So first thing, as you're trying to apply the law of cosine, I also written on next to the problem. When you're applying law of cosine, you want to go with the largest angle. Why is that? I mentioned in the class, if you forgot, the main reason is because if you are going with the largest side, you might have an obtuse angle, and only cosine will tell you whether it's an obtuse angle or not. Because if it's an obtuse angle, your value will be a negative value as you trying to take the inverse of it. And that is perfectly fine if your value of the cosine is a negative. Okay? So make sure if you're going to apply your law of cosine, you want to start with the largest side first. And then once you have the side angle pair, if you have one side and angle pair, so for this case, C is the largest side, the longest side, so I'll go with to find the cosine angle C. I will go with cosine angle C first to find angle C. So we have B squared plus A squared minus C squared over, so at the bottom you have 2 times A times B. Again, make sure you put the parentheses at the bottom so that 2 times A times B are being evaluated as a whole thing. So it turns out to be angle C happens to be an obtuse angle. So that's 104.4 degrees. From there, when you apply the law of sine, you want to go with the smallest angle first. So which one is the smallest? So the smallest side would always be right across from the smallest angle. So that's the basic information I look for on your test. So B, no. A is going to be the smallest angle. Why is that? Because A is the shortest side, okay? I was just trying to fool you there. A is the shortest side, so the angle A measurement should be the smallest angle. So once again, cosine, law of cosine, you want to go with the largest side. Law of sine, you want to go with the smallest side. And once you have the angle measurement for angle C, angle A, I will just use all the interior angle sum to any triangle is going to be 180. So use 180 minus the other 2 angles. Number 2. This is the case where I mentioned about side angle. How do I know there's going to be 2 triangles, 1 triangle, or none triangle at all? So you can look at the information and you can check whether the given side is it shorter than the other side but greater than the height. So that's something you can check. Okay, so for this case, I know my side A is going to be shorter than side B. So that's very obvious. Side A is shorter than side B, and it is longer than the height. So you want to calculate the height. Height can be calculated as 12 times sine angle 35. You can calculate that on your calculator and you'll find side A is between side B and the height from vertex C. And then you can calculate the numbers, and as I show you, there's solution 1 and solution 2. So make sure you check that. And how did I get the solution 2 triangle angle measurement B prime? So I used the information from the first angle and then take 180 minus that angle to get my angle A, B prime, C prime, the solution 2. So that's something you want to practice with SSA. Number 3. So this is also in the case of SSA, but angle A is an obtuse angle. And since B is shorter than A, and it is not going to be able to form another triangle, so we will only have one solution on this one. And then you can check your number here. Just to remind you again, if you're applying the law of sine, here you need a side angle pair, and we happen to have A right across from angle A. So that's the setup you can use to use law of sine. And I like laws of sine better than law of cosine because law of sine is only a degree of 1. Number 4, side angle side. So this should give you one unique solution only, side, angle, side. No matter who draws it, it's going to turn out to be just one triangle. And for we to calculate, it happens to be angle C is the largest angle. So C squared equals A squared plus B squared minus 2 times A times B times cosine angle C. So calculate your angle side C. And one last check again to see if your smallest side is across from your smallest angle, your largest side is across from your largest angle. So that's something you want to check. If the number did not turn out to be correct, double check, triple check. Question number 5 and number 6, if I remember right, these two questions also appears on your chapter test, and I did just change the number. So make sure you practice. Take a look at the graph here. How do I look for the information for the height? So any triangles, I can form the right angles by myself by dropping from one of these vertex and then make the perpendicular intersections with the other side. So for this case, I drop down from C, vertex C, to side AB, making a right triangle. And once I have the right triangle, I can simply use the law of the sine, because I am looking for the opposite. Okay? Opposite is the relationship, opposite over hypotenuse is the relationship of sine. So basically for number 5, HC, I can either take BC times sine angle 45 to calculate the height. And there you have the value there. So make sure you check on your answers. I think the answer should be 633.97 feet. 633.97 feet. And number 6, once again, it does show on your chapter test. So make sure you practice these problems. So first thing, I look at the longest side. So as you can see, the better trying to hit from the base to the outfield, C. So it's all the way. So it's just like the hypotenuse of the triangles that I show in color blue. So the hypotenuse of the one in color blue all the way back to the outfield. So that way I can calculate the length using the law of cosine and double check on the angle measurement there. Why did I get the angle measurement? Because in the base it's a square format. Any diagonal running through it will cut the triangles into 45, 45, 90 degree special triangles we discussed before. 45, 45, 90 right triangles for the base. And then you can calculate the other angles using law of cosine again. Law of cosine. Once you have this information, the length would be, so look for the information that you are asked to find. And this problem is on your chapter test. So you want to practice this one. Question number 7 and 8. We practiced a bunch of these questions for the last few days. And we spent quite a lot of time figuring out how to divide the polygons into triangles. So depending on the information you are given, you want to calculate the least amount of information required to find the areas. So one way, again, as I remind you at the beginning of this recording, how do I find the area to any triangles? So all I need is side, angle, side. So once again, you need the included angles. For any triangles area you are looking for, you need the relationship of a side, angle, side. And in particular, that angle would have to be the included one. So look at the given information for number 7. Do you have enough information to calculate A1 and A3 directly? Obviously it is. We have the angle measurement of 80 in A1 and we have the side 75 and 200. So we can calculate, we can come up with the area for A1 pretty easily. How about A3? So A3, same thing. We have the angle measurement of 50, so that the angle inside would be 130. 130, I use the 180 minus 50 because any straight line, any line has an angle measurement of 180. So do we have the side? We have 45 feet, we have 150 feet, including the angle measurement, 130. So obviously we do have the information to calculate A3 as well. So what's left is your A2. So what information do you need to find A2? You need the side, angle, side. So no matter what, you need the side, angle, side, the included angle. How would you come up with that solutions? So now since you have the information for A1 and A3, can you calculate the dashed line that dividing the polygons, and then from there you can calculate one of the angles as long as I have the side, angle, side, the included angle measurement, and I'm good. Okay, so for this case, I think I calculate the side from the A3 that's dividing A2 and A3. You'll notice that I have the side angle side of A as 182.2. So that's what I calculate using the law of cosine. From using the triangle A3. From there, I know I need is just one more triangle, and then I can calculate the areas. So make sure you practice this. This is definitely going to be on your chapter test. Number 8. So this is more like testing your bearings concept. So bearings, we always measure with north and south because that's the only thing we can measure in the world, in the natural world. With the compass, you can measure north and south only. So the bearings are with respect to north and south. Depending on the information you are given, for example, for first note, you have north 48° east. So you want to start with north, which points up on your paper, and then go east. So east, we designate it to your right-hand side. So from up to right-hand side, make that angle measurement as 48, and I mark it on my paper. The second information, you have south 70° east. So again, south will be pointing down on your paper, opposite of your north. And east, again, is to your right. So from down, make an angle of 70° to your right. That's the second information. Once you have this information, because north and south would make 180°, 180 minus the two angles gives you the angle in between. From there, you can calculate the missing side. Don't forget, speeds is defined as distance divided by time. Distance divided by time. And the very last question, number 9. Sketch each plot of length, describe and find its areas. So this is very similar to question number, the previous one, that you have to divide the polygons into multiple triangles, and it's basically just asking you to read out the stories and then find your bearings and follow along. So do practice this because it's going to be on your chapter test as well. And the information that I have, and try to write it down along the way as I read the scenarios. And we practice quite a bunch of the information, the same problems, or I shouldn't say same, very similar questions during our lessons. So you want to take a look at that as well to have more practice if you need to. But bottom line is, you cannot assume. Please do not assume the angle measurement. Oh, it looks like a 30°. Oh, it looks like a 45°. How do you know it's going to be 30°? How do you know it's not going to be 28.5 or 36.9? So you cannot assume unless you are given the information, specific information. And the only thing that you can assume, well, I shouldn't say you cannot assume all the time, but sometimes look at the information for your first line. From an iron post, proceed 1,000 meters northeast. So northeast, because northeast is like dividing the north and east in half, dissect. So we can say that it's cutting it in half, dissect the angle measurement from north and east, that would be 45. So that's the only type of question you can assume only. And for you to get the other angle measurement, you have to read out the stories and follow along. And once again, if you see anything that's a parallels, think about two parallel lines with the transverse. The alternate interior angle is going to be congruent. So that's something you can assume as well. And because we have that proof in our geometry class. Other than that, you cannot basically say, oh, my graph looks like this is a 30 degree. My graph looks like this is a 45 degree. Once again, no one told you that. So you have to calculate, okay? So make sure you practice this. And don't forget, as I mentioned on the vectors, vectors was the last section we practiced in this chapter. And the basic information is you need to find vectors are composed of magnitude and directions. Magnitude and directions. How do you find a magnitude? We use the distance formula. Some people like to call it the distance formula. Some people like to use the Pythagorean theorem. Basically, it's just looking for the distance between the 2 points. So please do not overthink when it comes to vectors magnitude. It is the distance formulas, or once again, some people call it the Pythagorean theorems. So it's up to you how you define it. Just look at the graph and then figure out the magnitude. How about the directions? The directions is you can use the tangent theta, y over x, which is the slope. So you either use the slope concept or you can use the tangent as we do in the this pre-calc class. And as you can see now, slope is just basically tangent. So if for students in algebra, do you think, or even pre-algebra, do you think that they are taking pre-calculus class already? Absolutely. The concept will not change because you are taking other lessons. It's just simply building on the previous knowledge, and then we give it a different name. A tangent is exactly the same as slope. So there you have it, the review of chapter 6. Practice and practice and practice. As I mentioned in the last section of our meeting on Friday, vectors problems will directly be taken out from your homework assignment questions. So practice that and you shall be good. You shall do good.